44, please. I want to go back to instantaneous rate of change. Yesterday, what I tried to do in period 2 did not go so well, but my goodness, did it go very well in this class. Delia, if I write over here, are people going to be able to see?
Where?
Over here on this board?
No.
So don't fall out of your chair to do it. Alright, so yesterday we started on this idea of instantaneous rate of change. You might just want to write this on a separate sheet of paper somewhere. Instantaneous rate of change. I say instantaneous rate of change, Ivan and other friends. Instantaneous rate of change is just another way for me to say derivative. It's another way for me to say, go find the slope of the tangent line. They're all synonyms. So you see instantaneous rate of change, maybe you think, oh, tan. Maybe somebody else is like, oh no, he said find the derivative. They are all the same. The difference though with instantaneous rate of change, there's usually a word problem. There's something that you're doing. Let me write the model sentence here. And then we're going to do it. Okay. When it comes to the instantaneous rate of change, here's what I'm looking for. You're going to tell me at x equals a, or maybe it's t equals a. And then you're going to tell me, I'm going to write this in a different color, what the function is describing. We're going to come back to this in a second. Describe. At x equals a, what the function is describing is either increasing or decreasing. And we're going to get that based on the sign, the SIGN of our instantaneous rate of change. And we're going to say at a rate, not an average rate, because we're talking about it in an instant, at a moment in time, increasing or decreasing at a rate of, there's always going to be some number. And this is where I know I lost the last class. It's the units. There's 2 units to consider. I'm going to be specific and say it's the units for the dependent variable over the units for the independent variable. The independent variable, friends, I'm talking about like the x. What you would put on the x-axis. The dependent variable is what you would put on the y. And I hope that makes sense, because what are we talking about? We're talking about a rate of change. Rate of change is always y over x, right? Change in y over change in x, we've known that forever. But I think what starts to happen in the word problems, we start to get all tripped up with, what do you mean this independent variable? What do you mean the dependent variable? What's going on? I think if it was just the sentence, you guys would be fine with the sentence. But it's looking at the word problem. So what I want to do, and this is where you're probably going to want to take out a separate sheet of paper so you can write these. I want to look at page 44. We're going to look at problem number 2. We're going to do this one together, and then you guys are going to get a good amount of practice time. Okay. A water main is broken, and a flow meter gives the rate R of t at which the water is gushing out of the pipe in gallons per minute, where t is measured in minutes since the pipe broke. Using correct units, explain the meaning of each of the following in the context of the situation. Before we do any math, I want you to talk to somebody near you. What are the things that are being measured right now? Not what are the variable letters, but what is it that we're measuring?
The minutes and stuff like that. Gallons per minute. You're talking about specific minutes.
So it's going to be gallons per minute and then
Alright, water main is broken. The flow meter gives the rate, so R of t is going to be a variable. Okay, I was listening to a whole lot of folks, and I think we're pretty clear. Our variables, we've got t and we've got R of t. What is t measuring? No, I want to be really careful. What is it measuring? Not how is it being measured.
Water.
What's T measuring? T is like time since the pipe broke. Okay, this is the what we're measuring. How are we measuring? These are the units that we're using. What are the units for time? Minutes. Okay? It is important that we get the what and the how separated here. I'm measuring time, I'm using minutes to measure. Now, on R of T, what I heard a lot of people say was water. Here's the problem with water. What are you measuring? The color? The flavor? How much? How fast? When you say water, what are we measuring? Go back and read the question one more time. I want to see 5 hands in the air for this. What are we measuring? You've got to be specific here. I see 1, I see 2. What is being measured? Don't use units. What's being measured? Just Jackie? Just Kevin? Delia? Kaylin, what's being measured here? The flow of the water. It's almost 100%. Read it one more time. You want to be specific here. Beto. The water that's gushing, there's an important word that's missing. Go back and read this again. You've got to get the description just right. 1. Water gushing out since the pipe broke. We're almost there.
The flow of the water gushing out at the pipe.
The rate. It's the rate. A water main is broken and a flow meter gives the rate at which water is gushing out. R of T is the rate water is gushing out. What are the units? How am I measuring? Not gallons. Gallons per minute. Getting this situated in your brain is usually going to be the hard part. Now, tough question. Which one is the independent variable and which one is the dependent variable? A clue? If you were graphing, the independent variable goes on the horizontal, the dependent variable goes on the vertical. What goes on the horizontal? Time. Time. So time is your independent variable. The rate is the dependent variable. So let's look at A here. When I say R of 5 equals 100, here comes the sentence. At T equals 5. R of 5 is equal to 100. What is it that R measures? The rate that water gushes out. What is that rate? It's not increasing. It's not decreasing. Look at the notation. R of 5 equals 100. There's nothing in here that says change. It's not derivative. It's not slope. We're just saying R of 5 is 100 at T equals 5. The rate that water gushes out is 100 gallons per minute. That's A. It is not a calculus question right now. It's a math question, it's an English question. There's nothing in here that says derivative. There's nothing that says tan. But how about this one? R prime of 5. R prime of 5 is equal to 2. As soon as I see that little prime, this is going to make it an instantaneous rate of change question. And here's how the sentence is different. At T equals 5, what is the function described? It's still the rate that water gushes out. Because of that prime, it is a derivative question. It's a rate of change question. At T equals 5, the rate that water gushes out, what's it doing? Is increasing. Is increasing at a rate of 2, right? That's the number. The units, we have to be careful here. It's the units for the dependent variable divided by the units for the independent variable. What are the units for the dependent variable?
Gallons per minute.
It's gallons per minute over minutes. If that unit seems like gobbledygook, you've seen units like this before. Gallons per minute is a lot like meters per second, like gravity, or like feet per second, feet per second squared. What you're saying in this first part is that Juan goes over to the pipe and he says, you know what, right now, water's coming out at 100 gallons per minute. But then, I almost said Karina because Karina sits there, sorry. But then Jackie says, okay, it's coming out right now at 100 gallons per minute. But how does that compare to what was happening before? Is it coming out faster? Slower? The same rate? The first number tells you how fast it's coming out. The second number is going to tell you how does this compare to what happened before. Are all the friends mostly okay? All right, so with that said, give me part C. Part C, dr dt at, what is that, t equals 10? Equals negative 3.2. dr dt, you know what this notation means. Gallons per minute per minute. dr dt at t equals 10 just means go find that derivative. This is instantaneous rate of change notation. The sentence is going to be similar. Okay. Name, Perez, Bravo, Roberto, Jackie, Jose Munoz, Martinez, my bad, Abraham. The corrections. You turned them into me this morning in my mailbox.
No. No, I'm not doing that. No.
All right, hold on. Okay, Jose's got a question, and we're moving on anyway. Here's what your sentence needs to sound like. I spent the time passing out papers instead of looking at papers. Here's what your paper needs to look like at t equals 10. What's happening? At t equals 10, what is it that R describes? The rate at which water is gushing out. What's that rate doing? Jackie, what's the rate doing?
Decreasing.
Decreasing at a rate of
3.2.
3.2. Get the units right. R is measured in gallons per minute. T is measured in minutes, so it's gallons per minute per minute. I really like this notation because it's got all the stuff. I can see the units a little bit better. All right, so with that said, I want you guys to try number 1, please. Number 1. Read it carefully. Make sure you understand the units. Jose, I'm coming over so you can ask me whatever your question was. I want all 3 parts. 3 well-written sentences. Yep.
So the question was, you know how you write the dependent variable over the independent
Yeah.
variable? And the independent variable is going to be gallons per minute
Yep.
over minutes. Who is the absence? Can't we just cancel off the minutes?
Okay. Of course not.
Guys both used to write like that. I was asking.
Get me the sentences.
Used to write the same. Technically, like the same.
So, Jose, when you say gallons per minute, think about it like numbers. A fraction divided by a number. Keep it, change, and flip it. So it's gallons per minute times like 1/2. Perfect. Good save. Gallons per minute is the same as gallons per minute squared. Which is why last year in physics, Mr. Tara kept saying meters per second or meters per second squared. Same. In the words of my darling 13-year-old, same. She would also then say mood for some particular reason. All right. Everyone seems pretty clear. We've got T. We've got H. T is time. H is temperature. We've got hours. We've got degrees Fahrenheit. The independent variable is time. And the dependent variable is going to be temperature. And the way that you check, which depends on which one? Does the time depend on the temperature? Or temperature depends on time? Temperature depends on time, so that's the dependent variable. Other people, they like to think of it graphically. Which one would you put on the x-axis? You put time. Which one on the y-axis? You put temperature. All right. A, I need a brave soul. H of 15 equals 72. What's the perfect sentence? 18 people, no brave souls for H of 15 equals 72. I love it. I get to switch to victims instead. H of 15 equals, and this is where nobody makes eye contact and everyone stops talking. They're just H of 15 equals 72. Let me give you a clue. At T equals 15 hours. What's happening? Juan, what's happening? The temperature. What's that temperature? At T equals 15 hours is 72 degrees Fahrenheit. Perfect answer. Perfect sentence. There is nothing in the notation that talks to you about change. I didn't use the prime, I'm not using any derivative stuff. Perfect. B. H of 15 minus H of 11 over 15 minus 11 is equal to 3.2. What the heck would I be doing with H of 15 minus H of 11 over 15 minus 11? What would I ever measure that way? It is a rate of change. It is a slope. I bet you in some other folks' mouth, like, slope? Good choice. Now we got to be careful. What kind of slope? What kind of rate of change? We have two flavors. We have average, which means an interval, and we have instantaneous, which means at a moment. This is like old school slope. This is average. So from t equals 11 to t equals 15 hours, what's happening? From t equals 11 to t equals 15 hours, what's the function that I'm measuring? The temperature. What's the temperature doing?
Increasing.
The temperature increases, now be careful here. It increases at an average rate. Average rate of 3.2. Get the units right. Units for H, not temperature. What are the units? Units. If this is temperature up here, this is degrees Fahrenheit. What's in the denominator? Hour. So it's degrees Fahrenheit per hour. All right, last one, C. H prime, what is that, 15? H prime of 15 is negative 1.8. Make me a proud papa. Get that perfect sentence. Get that perfect sentence. Get it wrong, I'm going to sucker punch you. But I'll do it off camera so they'll never know. If your sentence isn't starting with at t equals 15, you have not been.
Decrease.
Yeah, it's one of those, Jack. At t equals 15 hours, what's happening? H, our function H, Pedro, is describing rate. Right, you're not ready for rate yet. You've got to tell me, what does the function describe? At t equals 15 hours, what's the function describing? The temperature. What's that doing? The temperature decreases at, and if you want to be fancy, at an instantaneous rate if you want to, that's fine by me. Or you can just say at a rate. If you don't say instantaneous, if you just say rate, we're going to assume instantaneous. Decreasing at a rate of, what is that number? 1.8 units? Degrees Fahrenheit per hour. How many of you guys have that sentence? Or almost exactly that? Nice job. Go. Okay. So, we're going to shake things up a little bit. If you guys can go over to page 46, please. We're going to do a little independent practice. You are going to need your calculator in a little bit, and Abraham, you're going to drive the computer in just a little bit. What I want you to do is read this introduction at the top of page 46. And then there's 3 mathematical statements afterwards that I want you to write a perfect sentence for. We'll talk about this in about 3 minutes. Make sure you know what the variables are. Make sure you know what you're measuring. Make sure you know the units. Yes, I'm sorry. How dare I not update this to represent the new leadership at Southwest and Southeast? Mr. Newcomer? You forgot him already?
He's still there.
Who? Tall guy, ran the school for like 5 years. You must have spent a lot of time in his office. You must have spent time. He went to Costa Rica. You're going to college after you get these 3 correct. You don't even have to graph. Right now, it's just for parts A, B, and C. What are the perfect responses? What are those perfect sentences for those three? Newcomer and Mr. Schmidt. We can change that to Mr. Espinosa and Ms. Galligan. Friendly competition between the two campuses. This year's competition involves launching model rockets. The school which can build the best model rocket will win the coveted Yes Prep projectile prize. That actually doesn't exist. The height of the rocket built by the Wizards can be determined by W of T, where T is measured in seconds. And W of T is the height of the rocket measured in feet. Walking around, I saw just about everybody has already identified. We got T, we got W of T. What am I measuring with T? No? What am I measuring? Time. Hey, Jose, what am I measuring with? Oh my God. Seconds. W of T, what is being measured by W of T? Height. What am I measuring with? Feet. The independent variable? The independent variable is going to be time, and the dependent variable is going to be the height. All right, I need some brave soul. For A, W of 3.2 is 97.16. Go for it. What you got?
T equals 3.2
seconds.
The height of the rocket is 97.16 feet.
The height of the rocket is 97.16 feet. Love it. Way to go. Full point. Come on, he can do it. Everybody else can do it too. All right. Nice job. Perfect sentence. B, dW dt T equals 3.2 is negative 22.4.
I had a question.
Oh wait, Delia's got a question on part A.
So for that one, you don't have to say like that it's increasing, or
Why not? Why not, Abraham? There is nothing in this notation, Delia, that says rate of change. There's no prime. There's not the dW dt. Gentleman in the front, you're creeping her out. Okay? But Delia, it's the perfect question. Like, why are we not talking about rate of change? Because this isn't a rate of change question. That's why. Which means, though, you're ready for part B. dW dt at T equals 3.2. This is this is a rate question. Okay, so let's get started. At
T equals
3.2 seconds, what's happening?
the height.
The height of the rocket is decreasing
At a rate
average or instantaneous?
at a rate of 22.4.
At a rate or at an instantaneous rate of
22.4.
22.4. Oh, and then everybody gets quiet with the units.
Seconds over second.
Feet over
I mean, feet over second. Feet over second.
Feet over second. Y over X. Dependent over independent. Feet over second. How many guys honestly have like that exact sentence? Okay, we're in a much better place. Part C, W prime of 2.5 is equal to 0. Rate of change notation. At T equals 2.5. The height of the rocket, what's it doing? The height of the rocket is constant. I would stop there. If it's constant, you've stopped. You're not increasing, you're not decreasing. I want to get some hands on this. Why? What happened? What has happened with my rocket at 2.5 seconds? Pedro, what happened?
Reached the summit.
What?
Reached the maximum.
It's reached the maximum, it's reached the summit. There's another word you might want to use here.
Maximum.
It reaches the maximum, right? It reaches the, begins with the V. Ends in vertex, that's right. Vertex. Naeem, that joke does not get old for you, does it? Alright, so I want to show you guys some new calculator skills that you didn't previously possess. So if you could take out your calculator, Abraham, if you could assume the position. Oh, that sounds like he's about to get spanked. That's what I meant in the DeRozier home. Oh, I should have been second. Thank you for making me a better teacher. All right. With your calculator, please. I want you to graph W of t. I want to show you some new calculator skills that you maybe did not possess. We're going to ooh and ah like we always do with new calculator skills. Last class we had some confusion. They were like, how do I get W to show up? You don't. How do I put in the T? You don't. Negative 16x squared plus, what is it, 80x?
Yeah.
80x plus 5. Okay. Hold on, Abraham, before you do it up. Yeah. Abraham does not listen to me at all. I don't like this graph. When I say I want a complete graph, I want all the interesting places, Evelyn. I want roots, and I want a maximum. So fix that window. Now, some people might know about zoom fit. I don't like zoom fit. Don't do zoom fit. Wait, Abraham? Abraham? You are about to get fired. Hit the escape button. Thank you. Okay. We got the roots?
Yeah.
We don't have the maximum? All I want you to change, Abraham, is get me the maximum. The maximum's up here. We need to change Y max. So anybody find a good Y max? So you can do menu, Windows zoom, settings, Abraham. Abraham. Ay, Dios míos. Cancel. Menu.
Yeah.
Windows zoom.
Okay.
Windows settings.
Yeah.
There we go. The only thing we need to change is the max. Don't touch anything else, son. Change the max. Get me a good maximum value so I can see where that vertex is. And you might want to play around. Maybe it's 50. I don't know. Carlos, you okay back there? You look like you're in church and you're praying. Okay, maybe it's 50. Maybe that's good enough. The Y max, Abraham. Goodbye, insurance company. So just you can delete all that out there, and I think 100 is going to be the right way to go. It's all the time with the insurance companies right now. Okay. Good enough. I think 110 would have been better. We get up there. Okay, let's look at the numbers that we had. The first one says W of 3.2, what was that, 97.16? Which meant at time t equals 3.2, the height of the rocket is 97.16. How do we get that on the calculator? How would you get this value on the calculator? What do you do? Graph trace. So menu. Abraham, menu. Trace. Graph trace. And then you just type in 3.2. 3.2. Everybody good with 97.16?
Yeah.
Good, okay. Eric, what was the value in part B? Was it dw dt? At t equals 3.2, and what was that number?
Negative 22.1.
Negative 22.4. Now here's the thing. I'm asking you about the derivative. I'm asking you about the rate here. Hit menu. And analyze graph. Anybody see anything that might be helpful here? Ah, dy dx. No, I did not sneak into your homes last night and add this feature in. It was there already. So dy dx. And now the calculator is going to ask you a question. Position. What's the position?
I don't know.
3.2.
At 3.2. Type in 3.2. Ah, there we go. There we go. Not only does it give you the number, it puts the point on the curve. And what I hope is that this reinforces what you know. At t equals 3.2, what's happening on the curve? The curve is decreasing. The rocket's height decreasing. Check. Okay, last one. W prime of 2.5 is equal to 0. W prime. Derivative. Let's do it again. Menu. Abraham's really good. Now he's only moving when I say something. Analyze graph. He's getting brave again. dy dx. Position this time. Well, the position is 2.5. Position is 2.5. Right up there. The number is the slope in this case, not the height. All the friends are good? We got some new calculator skills?
Yeah.
Excellent. And we've got 2 minutes left, so I want to move you guys on to part D. Abraham, you can come back and join the rest of us. Thank you so much for your service. All right, part D, no calculators. New problem. Let's see what you can do. The height of the Mavericks rocket can be modeled by the function m of t equals negative 16t squared plus 64t. Again, t represents time in seconds since the rocket was launched from the ground, and m of t is the height. Determine the value of m prime of 3. Show me what you can do. M prime of 3. What would you do? Four people are off to an excellent start. 4 people are on the board. If I'm going to find m prime of 3, you have to find this, and you don't get to use the calculator. M prime of 3 means I need the limit as t approaches 3, m of t minus m of 3 over t minus 3. So this is just going to be, we're not going to have a chance to finish it. But limit as t approaches 3, what's m? This guy up here, negative 16t squared plus 64t. Minus, if I plug in 3, that's negative 144, that's 92. I think you get negative 48 over t minus 3. Here's what I care about with the little time that you guys had. I hope just about everybody said, oh, you want the derivative? I know how to get you the derivative. And we use the right function with the right letters at the right point. And I'll tell you, if all goes well, 96, you're going to get negative 32. But it's minus, yep, plus 48. All right, thank you for making me a better calculus teacher. Tonight's homework, lesson 16, page 41. See you later. Hey, Ashley, what flavor is it now? Me? Let it go. Okay. No, free dress day got confusing, got me breaking all the rules. I always see the gum.
Boy, you don't even know where you're tread.
Do I turn off the camera?
Yes.